CPM Math 3, Problem 1-91. We are being asked to multiply some expressions here. So for part A, you can either use an area model or the distributive property. It does not matter. I'm just going to simply use the distributive property, plus 1x minus 1x minus 1. That simplifies. These guys cancel each other to x squared minus 1. Over here, we actually have three factors in the expression, so we'll have to do more than one multiplication. What order do I like? Let's go this way first, all right? So we only multiply it into 1, so 2x squared plus 2x. Now that factor has to be multiplied times this x plus 1. So now we can use the distributive property again. So 2x squared times x is 2x cubed. 2x squared times 1 is plus 2x squared. Now this guy, 2x squared times 2x is 2x squared, and 2x times 1 is plus 2x. And then we do have to combine like terms, so we get 2x cubed plus 4x squared plus 2x. There we go. All right, so we have our two solutions here. This guy, same thing. We're going to have to do more than one multiplication. All right, so x squared plus x minus 1, and we can cancel these guys out. We get x squared minus 1 times, now we have to multiply him by the x minus 2. So x squared times x is x cubed. X squared times negative 2 is minus 2x squared minus 1x. Negative 1 times negative 2 is plus 2. And we don't have any terms that we can combine. So that's it there. Part D of this problem is asking us to find the x-intercepts and the y-intercepts. And in order to find the y-intercept, we want the x piece of our ordered pair to be 0. So let's substitute 0 for x and see what we get as a y-intercept. So 0 cubed minus 2 times 0 squared minus 0 plus 2. Well, all of these guys are just 0, so the y-intercept is 2. Imagine that. 0, 2. So that is the y-intercept. There we go. For the y-intercept, or excuse me, the x-intercept, we need to make sure the y piece of our ordered pair is 0. So what we would do is substitute 0 equals x cubed minus 2x squared minus x plus 2, and that is seriously overwhelming. But they've given us a hint that if we go back and look at these factors, because we can actually rewrite it as the x minus 1, because notice how this is the same as this. We can rewrite it as the x minus 1, x plus 1, and x minus 2. And therefore, if x was a positive 1, we would end up with 0 times whatever these are. If x is a negative 1, we would end up with this factor is 0, so it would equal 0 when we multiply everything through. If x is 2, and would make this factor 0, it doesn't matter what these are because 0 times anything is 0. So there are actually 3 locations where this particular function will cross the y-axis. We have 1, 0, that's this one. We have negative 1, 0, which is this one, and we have 2, 0, which is this guy. So 1 y-intercept and 3 x-intercepts. Pretty cool, pretty cool.